Now we will be working on problem 51. So for problem 51, we're working with the usual topology. So the topology is the set of unions of A and B where A and B are in real numbers. And we want to let En be the interval 1 over n to 1. And first we're going to find the union of all these. So starting off, we have E1, which is 1 over 1 to 1. So 1 to 1. And I'll draw a figure over here, 0 to 1. This one is 1 to 1, so it's a point. E2 will be from 1/2 to 1. So 1/2 to 1. E3 will be 1/3 to 1. So 1/3 to 1. And E4 will be 1 over 4 to 1. And we don't stop at 4. You would keep going, but from here we can see that the pattern is going to get closer and closer to 0, but never really include it. So we'll say that the union for En is equal to 0, 1, only including 1. And now to prove this, you have to show that it is a subset in both ways. So we will start with this one. This is the side we start with because of the direction that is facing. So we will let our X exist within the union, and I'm going to write En for time and space to say time and space. And our goal would be to get that X into the other side, which is equivalent to, if it's in that interval, then it's greater than 0 or less than or equal to 1. So if X exists in the union, then there's a n in natural numbers such that X would exist in one of these intervals of 1 over n to 1. So one of these will allow X to exist there. And like we did over there, we're going to rewrite this as X is greater than, I'm going to need more space. X is greater than or equal to, because we have the bracket, 1 over n, or less than or equal to 1. And we know that we saw over here that 1 over n does not hit 0, which is why we don't include it. So we know that 1 over n is greater than 0, and we can include that over here now. And so by transitivity, I'm sorry, I'm getting confused if it's transitivity or trichotomy, but I'm sure it's transitivity. Then 0 is less than X, and X is less than or equal to 1. And that's the first part. So the second part now our symbol is facing in the other direction. So we will let x exist in the interval from 0 to 1 this time. And now we want for x to exist in the union of en and to write an equivalent, as we saw in the previous one, that would mean that there would need to be an n in naturals such that x exists within that interval 1 over n to 1. And we'll just rewrite this part at x is greater than or equal to 1 over n or less than or equal to 1. And very quickly, we'd want to check, is there an n in naturals such that 1 over n is less than x? And this is the Archimedean principle. If you can solve for n, then there is an n in natural. So this one turned out to be simple. You just multiply by n on both sides and then divide by x. And so yeah, there's an n. And so now when we move over here, we rewrite this to show that x is greater than 0 or less than or equal to 1. And because we saw that the Archimedean principle is true, 1 over x exists in real numbers by our Archimedean principle. And so there exists an n in real numbers. And now we solve for the n, which is basically gonna return what we had over there, and x, and we solve for the x, not the n, and 1 over n less than or equal to x. And we have this as well, but x is less than or equal to 1, so 1 over n is less than or equal to x less than or equal to 1, which is what we have over here in our equivalent. So therefore, they are equal. And the second part of the question says that is the union of the closed sets closed. We know that the intersection is, I read that within the notes. But first, let's find the closed sets. So if it's in the topology, it's open. You know, this is open and the union as well. A single one interval would also be open. And then these three would not be open because if you draw a line and you want to choose intervals like from A to B, if you choose like A to B, you can choose as many as you want, but we can't include anything with a bracket because that would require our interval to be past that to include it, and then we shouldn't include anything that's not within the interval. So that's why these three with brackets would not be open. And then that these are their complements. The set is only closed if its complement is open. The union of ABs is similar because this we will require unions of these brackets to be open, or even if it's just one, we know that if there's a bracket, it won't be open, so these are not open. And these two would be similar, where if you have A, B, well, now the complement would exclude that one and include this one, meaning we have a bracket, so their complements would not be open. And now for this one, the last one, I believe it would be closed, because if we have union or even just one, but I'll draw two just so we can see, the complement would not include those, and it would not have brackets whether it's just one or two. So the complement is kind of like these two, which are open, so therefore that one would be closed. And now the union of these three sets, the empty set, the real numbers, and interval with brackets, I'm sure that this interval would be a subset of the real number. So this union, the reals, union, the empty set should be the reals, and if the union of the closed sets goes, or if it's just the reals and the reals is closed, I say that the union is closed. And that's it for number 51.